Hello everyone, welcome back. So today what we'll be doing is the Penrose tiling using give me a second, I just don't remember the name, the P3 television. Um, so this is the end result we want to achieve. Um, this is what it should look like in the end if we get this right. So I've done it once before to get the concept in there. So I will refer all of the pages I have currently open in the description of the video. So the first one is just the Wikipedia page on it. We won't be passing too much time on this, but this is this Penrose pattern, I believe, was created from Roger Penrose. And it's basically a non-repeating tiling. So if you, let's say if you were to take just a portion of the tiles and move it across, you could find an exact match. But if you were to move the whole tiling over, you would never be able to find an exact match. So I'll be linking down in the description down below all of these references. So let's get started. Let me go in on the whiteboard and explain the principles. So there's going to be a lot of things on the whiteboard, so I might be erasing some stuff to make some place, right? So first thing we need to do, so the name Penrose Tiling, right? So the first thing you have to understand is that Penrose tiling uses triangles, two different triangles, and those triangles are what are they called? Sorry, give me a second. Hopefully I pronounced this right, but isosceles triangle, right? So isosceles triangle. Let me just write it down. Isosceles triangle. So those triangles are basically whenever you have a triangle where two sides are the same length, and by that fact, the two angles opposite to those sides, right? So opposite to those sides are the same length as well, right? This angle, we will call it the apex angle. We won't be using it that much. And these angles, we'll call them the commons. I don't know. This is just my naming. Yeah, so basically it is made up of two different isosceles triangle. One where, so the triangle, they got them from getting I don't remember the name of this shape in English, but this shape, well, technically this should be the same length, but I'm not really great at drawing, and the same shape again, but a little bit wider, let's say. Well, if I can at least do it. There we go. Hopefully that's better. Well, anyway, so splitting this one horizontally and this one vertically. So this will be one of the triangle we'll use, this section over here, let's say. And for example, this one will be the other triangle we'll use. So those two triangles are the ones we'll use. The really important part, from what I've seen and what I've had issues with, is the angle for the common angle, basically. They need to be specific angles. So I'll be sharing that later on, but that's not the important fact. Well, it is an important factor for it to work, but for the concept, for us to understand the concepts of the Penrose tiling, it doesn't really matter for right now. We'll get the basic principle there. So the first principle that we need to understand to get this working, at least my implementation of it, is we need a little bit of trigonometry, right? So given an isosceles triangle, right? So I'll remove the common and apex writing over there. just to give us a little bit more clarity. Great. So this is, let's say, A, B, and C. And this is, let's say, A, B, and C, okay? Where A and B, the angles are the same. We could write this like this. So angle CAB, so this angle CAB is equal to the angle CBA. All right, so this is the same. These are two equivalent angles. And whatever is left from 180 minus those two angles is the apex angle C. So, and we also know that C and B, or you can write it as AC, straight line above, equals the same length as B and C, or C and B, but it doesn't matter. So those are the same. Let's say you do, and this A is also called the base. Base. And we'll use that naming convention later on. So A is also known as the base. And let's say you do have the A value, the A length, right? Let's say you do know the length of A, right? So let me just move. I don't know if it'll be easier to write. I don't know. Let me stay here for the moment. Let me just make sure you can see everything. Oh, yeah, I think you should be able to. Okay, so let's say you know A, but you don't know B, or you don't know C, right? You know that if you get B, you know C, right? The length, I mean. But you don't have those. But you do have the common angle and A. So how would you go about getting the value, this point, basically, this C coordinate, right? So let's say, I'll just redraw this. So let's say this triangle here, given that it's an isosceles triangle. And again, A, B, C, those are the points and the angle at the same time. So given that you have the AB length, so let's say in this case, this, let me do more straight line. So this length over here is, let's say, 30. And you want to figure out this point over here, right? So what is this XY coordinate, right? And you don't know that, but you know this XY coordinate. So let's say AXY is, let's say 0, comma, maybe, I don't know, something that wouldn't make sense, but let's say 50, right? I don't know, maybe. And B is, let's say it's 30, definitely. So 30, comma 50 as well. 50. Okay, right. So you know these two coordinates, but you don't know this one. And you know this specific angle, or this one, right? Both of them are the same. So let's say that angle, I don't know, CAB is equal to, and I'll do all of this in degree, and we will eventually use radians in the code, or we could use degrees. I mean, we'll see. Right now I'm just going to use degrees, so 0 to 360 for a full circle. So let's say that this angle here is, I don't know, maybe what would make sense? Close to 90? I don't know, maybe 60 degree, I don't know, maybe, let's say a little bit less than 60, because 60 degree, that would mean it's a equilateral triangle, right? So let's say 55 degree. I don't know if that's actually the case based on the drawing I've done, but let's say it's 55 degree. So this one is also 55 degree. Now to get this point here, right here, what you can do is use trigonometry by basically splitting this isolated triangle into two right angle triangle, right? And you know, because since you're splitting it in the middle, and this line, we will call it, give me a second, I've wrote the name, we'll call it the bisector. So this line and this new point at the bottom, we'll call it D, right? So let me erase the 30 here. We know the length is 30. I'll just write it out as well. So we know the length of AB is 30. Well, this is not a beautiful tree, but anyway, doesn't matter. And this, we'll call it D for that point. So this line here is called the bisector. Let me just make sure I've written that properly based on, yes, okay, great. So this is the bisector line. And in the end, it will arrive in the center of the line that goes between A and B, right? So we definitely are able to figure out this and this length, right? The length of both of these, which is basically this length, right? So let's say AD is equal to AB divided by 2, right? That's half of it. And the same goes, and I'll just put another equal there, and D to B is also equal to AB divided by 2 in terms of the length of it. Great. So we know the length. So let me redraw this a little bit bigger. Okay, great. So this is D, this is A, this is B, and this is C. Okay, great. So we know this length. In this case, it's 15. This length we don't know. And this length we don't know. And this we know is a right angle, and we know that this angle here is 55, right? So I'll just put angle 55 degrees. Okay, great. So we know the angle here is 55. We know this one is 90 degrees. We know this is 15. How much is the length of this one? And using that length, afterwards, we can just rotate 90 degrees from the D point and set the length, right? So what we can do is just basic trigonometry. So let me go in. So it's been a while since I went to school. High school. So I didn't remember, but I've just looked it up. It's not really that difficult. So let me scroll right here. There we go. And I'll be putting this link down in the description down below if you want to take a look at it. So I was looking at this image here, where we have all the formulas to get, basically it's giving us all of the information we need for what we want to do. So given this angle, right, which we haven't calculated yet, but we know how to, it's not complicated, we'll do it. So we need the angle that we don't have yet. And we want the opposite, but we can get this angle easily. We know this opposite value, right? We know this is, for our example, it's 15. We don't know the adjacent, but we do want the adjacent, right? So let me zoom in a little bit. So we can see it here, right? So it's tangent of the angle is equal to the opposite divided by the adjacent, right? The adjacent is this one. Opposite is the one we know. So let me write that on the whiteboard. Let me switch back. Give me 1 sec. Okay, there we go. So we know tangent, and this is theta or the angle. I guess it's a wavy. Yeah, I don't know. I'll just call, yeah, sure. So tangent of this angle equals, we said, opposite over adjacent, right? And this over here is opposite. Sorry for my poor handwriting. Opposite and adjacent is here. We don't know. Yeah. So tan of the angle equals the opposite over the adjacent. Is it a J or I don't remember, sorry. It's a J. Really sorry. Adjacent. Okay, great. Adjacent. Okay, all right. And we can convert. So first thing we need is this angle here, right? So how do we get this angle? It's not complicated. Every triangle has a total inner angles of 180 degrees, right? So all of the triangles within a triangle, summed together, give us 180, always. There is no exception to it. I mean, not that I know of. Could be wrong, but not that I know of. So we know that this angle plus this angle plus this angle gives us 180, right? So what we can do is just really simply just get the angle that we're missing. We already know the other two, right? By doing 180 minus, this one is 90 degrees, so we'll do 90, minus the other one that we know, which is, we said this one is 55, right? 55. And now we know the angle is, so here, this is 90 minus 55, 40, 35, right? 6, 4, 35, yes, 35, right, I believe. Hopefully this is right. Anyway, so we know the angle is 35 degrees. So we know 10 of 35 equals the opposite over the adjacent. And we want to figure out what is this adjacent value, right? So we can just multiply by adjacent on both sides, which will move it like this. Adjacent times the tan of the angle equals the opposite. All right, great, but not exactly, right? We want the adjacent alone, right? On its side alone, right? So what we can do is just divide by tangent of the angle on both sides, which will result us to the opposite over the tangent of 35 in our case, which will give us the adjacent. I really hate the red marker, but anyway, adjacent over here. Great. So now we know this adjacent value, right? This interrogation mark is not unknown anymore. We do know the formula to get that. Great. So now we have pretty much the base principle over which we will use to generate the tiling that we want. Okay, great. So now I will need to erase, maybe not right now, let me just think about it. What next, right? So, okay, I'll explain a little bit more how the Penrose is creating itself. So, well, one way to create it, it's create it. So I will be removing this over here just to get a little bit more space. But hopefully you can always come back to this time on the video and check it out if you need some reference point. Great. Let me pick back the marker. Okay, great. So the Penrose tiling, we start, so how I do it, which is also based from the other page I was looking at, which will also be linked in the description down below. But how it is done, the way I did it, which was taken from somebody else, is starting with whichever one of these two triangle, and then iterating over them. And what I mean by iterating is basically deconstructing them into other of those two triangles. So let me do, how did they call it? Give me 1 second, I'll just give you. So they call it substitute. So we start with, let's say, this triangle, and we substitute it with different triangles, but it will take up the same space. So the substitution for those two particular triangle is, so this one, the more long one, and the more thick one. Let me redraw this. So, right? So there's two substitutions for both of them, right? So 1 and 2, and 1 and 2. So there's two substitutions for each of them, right? So in this case, let's say this one is 1, and this one is 2, and this one is 1, and this one is 2, right? So the one that is lined is 2, and the one that isn't lined, the one that is lined is 1, and the one that isn't is 2. We're gonna get there. So let me draw all of them. So this is, let's say, 1, but they are the same, right? 2 and 1 are the same, and 1 and 2 in here are the same as well. It's just they won't be substituted the same way, right? So these two, and we have, again, same ones, but not the same substitution for these two. And I'll just write substitution. It's not really pretty, but anyway, doesn't matter. So this result into, let me take a look back at my references just because I don't remember by head, but give me once again. Okay, great. So over the long way, okay, great. So this one, over its one of its longest sides, we will create, from this point and this point, we will create a new large triangle. And this one will be, if I remember, and this one will be this version of it. So whenever we'll want to substitute this one, we'll refer to this substitution method, right? And this one will be this one. So again, whenever we want to substitute this one, we'll substitute based on this rule. Okay, great. So now we have this. What is this one? Well, my representation is not great. This one is the light one, which is, okay, top. Okay, great. So let me redraw this line a little bit. Okay, great. That's a little better. Okay, so in this case, this triangle is something like this. Yeah, I mean, it's not two sides and perfect, but it doesn't matter, just for the sake of the explanation. So we're starting from here to here to here. This is supposed to be the same length as this one. Obviously it's not, but it's supposed to be. And then we do this one, which this line is supposed to be the same as this one, and then this is a small one, right? So this is the version, the light version, right? So this one over here, and then this one is the same that was just in here, and this one is this one over here, right? So this one is light, is the first one. This one is the empty one, and then this one is also the empty one. Great. And now the last two is basically, let me make sure I get it right. So it's basically the same thing as this one over here, but this time it's the other way around, and I believe, no, never mind. It's difficult. Okay, there we go. So let me erase my arrows just so it's a little bit cleaner. Let me just erase it. I'll just redraw it. It'll be a little bit easier for me. Okay, that's fine. So and like that. Okay, that's a little bit more clear. Yes. So I was mistaken. So this one is the one that is the current one, the same as the current one for the substitution, and then this one is this one, and this one is also the small one, the first small one. Okay, great. I believe that is correct, right? Oh, and this is the small one. We're going to get there. Okay, and then again, the small one, I believe it is the same as this one, but instead of splitting it from here, we're splitting it from here, and also we basically inverse. So this larger one will be the one that is over there, and this one will be empty. Correct. I believe all of this is correct. Yes. Okay. Now, last one. We're gonna get there. So we subdivide it into basically the mirror version of this one, just like the above one. So in this case, it'll be something like this, and then something like this, right? And in this case, only this part is the different one. Great. There we go. So these are the substitution rule. And why I wanted us to understand this principle here, how to figure out the C point without knowing it, but knowing A, B, and knowing the length between A and B, which is not complicated. We can just use some distance function between A and B to get that distance, is because here, for example, right, we will first create, whenever we substitute this triangle for this one, for these two, we will first create this top one by creating it from its base, always creating the triangles from their base, because we know how to get the top point from their base. And the angles are always going to be the same, regardless how many substitutions we do. So in this case, we'll know that the C point from this triangle and the A point from this triangle are the base A point and B point for this new triangle. And then we can figure it out for this one, which this point, which is the B point of this one, will be the A point of this new one, and this point, which is the C point of this one, will be the B point of the new one, right? And this is the same principle applied for these other three. So that's why we needed to know how to get this C point from that. And basically, to get C, I'll just write it out. But let's say we know A is equal to, let's say, X, Y. And these we'll be using P5 vectors for this, just not to overcomplicate things with more math. And B, hopefully this is accessible to everyone. Hopefully the explanation are good enough and valid enough. Correct me if I'm wrong. But to get C, what I'm thinking is we need the D point first. We need to get the D point to get the C point. So we'll get D. This is not an O. This is supposed to be D. Okay, D point is basically the midpoint of A and B, right? So what we can do is use, so I'll just get down a little bit so I write straight, but it's basically for the X value, it's the lerp of the value of AX and BX. So this is for the at 0.5, right? Lerping in the middle. And then the second value, which is the Y of the D, because this, technically, if it was straight line, like a horizontal line, we could just get the middle of X and that would be it. The height would stay the same, but this could be oriented in whatever ways, right? So it's important that we basically lerp based on where those points are currently at and not what it could be, right? Because the angle could be anything, right? So, okay, so we lerp between those two, and we lerp again for the same way, but for the Y value. So lerp AY, lerp BY at 0.5, 0.5, there we go. So this is the vector for D. So we know the D point now. What we can do, so now we need the length of This is the opposite. So opposite will basically be the distance between B and D or A and D. It doesn't really matter. We'll do it with B and D just because that's what D and B, it doesn't matter. So I'll just do, I'll just call it dist and just a function. So dist, passing it the two vectors we want the distance between. So B and D. This will give us a number, which will be the opposite value. Great. We should also know preemptively this angle, because the angles won't change, just like I said. So whenever we want to create this triangle, for example, we'll know what the angle should be for the common angle, right? So let's say angle equals, in this case it was what, 55, I think I said. Is it CAB? Yeah, so let's say angle, we'll keep the same example. Let's say the angle is 55, right? And we know, using our function, we can figure out the length of the bisector, right? So we'll have bisector. Hopefully this is not too small. Sure, hopefully it's fine. Bisector length will be equal to, we said it will be equal to the opposite over the tangent of the angle. So the opposite I'm writing divided by the tangent of the angle. Right, there we go. So now we know the length of the bisector. Now all we need to do is take the D to B vector, right? Basically D to B will be our C, will be, and to get D to B vector, it's basically subtracting D from B. So what we want to do is, So what we want to do is basically sub from B, we want to sub, I won't put a minus here, I'll put comma because it's a function call, comma D, right? Not B again, but D, right? So we want, basically, if you have, let's say you have your, over here it's 0, 0 on our canvas. We have, let's say, our D point, which will be, let's say, over here somewhere. So this is D, and we have our B point, which will be over here, B, and this is what we want. This vector is the only thing we want because we don't want to rotate from the origin B, right? We just want to rotate from the B. So we need to only get the D to B vector, right? So let's say this is, let's say 3, this is maybe 4, and this is, let's say 2, right? So D is 4, 3, not 3, 4, 4, 3, 4, 3. Hopefully you're still able to see, yeah, 4, 3, and B is 4 plus 2, 6, 6, 3, right? And what we want to do is subtract both of those. Subtract D from B. This will move B over here, right, to the origin, which will only be the space, the vector that goes from D to B, basically. So this is the new D, basically it's C, what we have currently in here for C. But now we want to move it vertically 90 degrees, well, not necessarily vertically, basically it depends on what the current angle of D to B is, but we want to rotate it minus 90 degrees, right? So because of the right angle here. So what we can do is dot rotate. I'll spare you the math for that. You can take a look at how to rotate vectors. It's not really complicated. Minus 90 degree, right? So we rotated 90 degree, great. Now we need to set the length of that vector. So now it's not over here anymore. We've rotated it 90 degrees. So now it's over here, right? This is, let's say C, right? So C is now here, but it's not necessarily the right length. It needs to be whatever bisector is, right? So we need to update the length of this vector to be the bisector length. So what we need to do is just set the magnitude of the vector. Magnitude of the vector is the length of that vector. So we need to, I'll just continue over here. Dot set magnitude set mag with the bisector. With the bisector, there we go. Okay, great. So now we would probably have moved it up a little bit, right? Let's say C is now over here. What we need to do now is move back C origin to D, right? We need to move it back over here. See, it needs to go there. We don't want it to go there. We want it to go there. So what we can do is just add back. So what we did to put it here is subtract D from B. So now we just need to add back D. So dot add D. There we go. So now we know the C point. So we're pretty much done with that. We know how to get our new triangle. And this will be the same concept for the larger triangle because they are the same kind of triangle. Thus, we can use the same principles, same formulas on them. Great. This was the hard part of the thing. Now, I'll give you a couple of seconds to take that in, and I'll be erasing a lot of things on the board since we'll be making the pseudocode now to implement this. So, all right. Oh God, it's not erasing anymore. Sorry. Okay. I should not necessarily have removed that. Anyway, I'll keep the ones on the right. The substitution rules. So, sure, that's fine. Okay, so let's think of it as one class. Maybe the class is called just thinking right now. We can call the class Penrose Triangle. Oh God, this marker is no longer living. Anyway, didn't like the red marker, so we'll go with orange. Hopefully that's visible on the screen, on the camera. So we'll have the Penrose Triangle class, right? So this will be the name of our class. So what should the class have inside of it? It should have at least 3 vectors, right? So A, B, and C. So A, it'll be X, Y. Same thing for the other 2. Great. A, B, and C. 3 vectors to start with, right? It's a triangle. It'll also have, right, so it should know whenever it gets subdivided, right? Is it subdivided or not? So we can have like a subdivided value, just a boolean, I guess, set to false by default. Sure. And then we will also want a sorry, just thinking. Yeah, a list, an array, a list, whatever you want, a list of other of subdivisions, right? We can call that subdivisions. Or triangles, or whatever you want to call this, which will be an empty list to begin with. Whenever subdivide is true, then subdivision should be containing those triangles, right? So it should also have its type, I guess, or its subdivision type. We'll call this 1, 1, 2, 3, and 4, right? So let's say type. I'll call it type for right now. I don't necessarily like type, but it's fine. So type will be provided by the constructor, the same as ABC, right? So it'll be some type of number. And I'll just put the list. I'll just put the list 1, 2, 3, or 4, right? One of those, valid. Great. So that is pretty much it, I believe. And we will make this into a function called get apex, right? Because we said that this point is the apex point, apex angle, apex point. Maybe we call this apex function or something like that, right? Which we will call whenever we create new Penrose triangle. So now what we want is a function or a method in the class to subdivide, right? So I'll just write it up just so that it's easier for me. But and I'll erase this number just to rewrite them a little bit more to the left, to the right, just so it's just to give me more space, I guess. So 1, 2, 3, 4. Okay, great, that's fine. So we'll have over here we'll have a divide or subdivide function, I guess, whatever we want to call it. Yeah, I'll call it subdivide. Subdivide, great. Now we want a either like case statement or if condition, but we need some type of condition to know which one of those type we need to subdivide with, right? What's the rule for the subdivision, right? So we can say something like if type equals 1, then do this subdivision, and then else if do this one. I'll be only explaining it for the first one, and then we'll code it for all of them, but I'll be just showing the principle for the first one, right? So, and we called that function apex, right? Apex. Also, I'm thinking we might want to also have the common angle in here, right? I'll just call this angle since we're not going to keep track of the apex angle, but I'll just call that angle. And angle is going to be provided from the constructor. So angle number should be, or technically we should know based on the current type that we are in the angle, if we were to make the angle global, I guess, but yeah, sure. I might do this a little bit different. In what you'll be seeing today, it'll be exactly this, but I might do some refactoring later, and the code on GitHub might be a bit different. But let's say we pass in the angle in here, right? And apex here is also going to be receiving a, b, and an angle, right? Just because we'll need that angle, right? It's a must. We must have that angle. So, and this is the common angle. The apex angle, we'll call that apex angle, but we won't be using the apex angle directly. So, okay, sure, it's a number. It's an angle, but it's represented as a number. Okay, great. So now we need to add into subdivision two triangles for the first case, right? So if type is 1, we need to subdivide into two triangles. So I'll just call subdivision S index 0 should be equal to a new Penrose triangle. I'll just do capital T for new Penrose triangle just because I don't have much space. And what we need to pass it, right, is it's ABC and then the angle and the type, right, the type. So this type is this is the big empty one, which is, I believe, the fourth type, right? So 4. This one is the first. Was that right? Let me make sure this is correct. Yes, I believe it is. Yes, it is. Is it? Yeah, I think it is. Sure. Okay. Yep. So this is 1. This is 4. This is 1. This is 2. This is 1. No, sorry. This is 3. This one is 2. This one is 4. This one is 2. And this one is 3. There we go. So we need to pass it A, B, C, and type and angle, right? So the first triangle we want to create is the subdivisions we want to create is this 4 over here, right? So the A value should be this point over here, the top point, right? Because we go like that, A, B, C, A, B, C, right? Or A, B, C. There we go, right? So from the base starting point, I guess, is A. So the A value here should be the C value of the current triangle, right? Of this dot C. Okay, great. Now we need the B. The B should not be complicated as well. The B, it's just the A value of this one. So this dot A, right? This dot A. There we go. And now for the C value though, this one, we will use the apex function, passing it the angle of this triangle, of the 4 triangle, right? The common angle over here. Which we can have as a global variable, I guess. We don't necessarily need it here, right? We don't need this here. We'll make it a global variable based on the type that you receive, right? So Apex could just receive the type, and I guess, yeah, it could just receive the type, and it'll just check the global variable for the angle. Yeah, that's fine by me. So here we'll call Apex with the type with A and B, which is this dot C and this dot A. We could do this like very many different ways. Just doing it like that. Previously, I haven't done it like this. I've done it a different way. And then the type, so it's 4 in this case. And then the last argument should be the type, right? So I'll remove this and it'll be the type, which with the type will be a number between 1, 2, 3, or 4. So in this case, it'll be 4, right? And that's it. Now we've created this 4 triangle over here. And now the next subdivision, same concept, the next triangle for the subdivision. So S index 1, same concept, right? T, new Penrose triangle, passing it T, which will be A will be B, right? So this dot B as the A value, and then B should be the C value of this one. So S index 0 dot C, and then we call For this one, we technically don't need to call apex. We can just pass it, since we already have it, we can just pass it this dot a, right? And then the type should be 1, right? There we go. So this, and then we do else if for type 2, and so on and so forth, right? So, but I won't be writing it like this on the whiteboard. But this is the concept. And we can have an if condition, like if already divided, just call subdivide on the subdivisions. And after this if else, we can just set subdivided to true. And we'll also create a show function just to render triangles based on the 3 points of each triangle. But that's pretty much it for the concept. So let's try coding it, and we'll see what happens. And we will be using radians and not degrees. Just for us to just to mention. And I have 4 colors here for the 4 different types, and I will be changing it a little bit. So I'll remove everything else. I'll just keep the setup. There we go. I'll remove all of this, all of that. Well, I can keep no fill, no stroke. I'll keep background, no fill, no stroke. Sure, that's fine. Well, no fill. Well, yeah, sure. White. Okay, great. So let's first start with the apex function, right? So not config, sorry. So we'll have a function called apex, which will receive 3 arguments, a, b, and the type, right? And we will right now create the variable for the type. Oh, I did not mention it, but the angles are really important, which angle you choose. At least I found that it was primordial that you knew that. And it wasn't mentioned. I mean, I didn't search that much in this paper. I was more looking at the images, to be honest. But the angle wasn't mentioned up to this section. I haven't read further down. I would suggest for you to read it. It's really a great read, at least for right now. I will end up reading the whole thing eventually, but he's talking as well as a different way to 3 different ways to do the Penrose tiling. This is the one we're doing, but there's 2 other ways to do Penrose tiling. Well, there's a lot more, but he's talking about 2. And he wasn't mentioning the angle up to now. So I found out this paper from claymat.org, which I'll be also sharing in the description down below, which was referring the angles, as you can see here, right? But in our case, it's, let's say we split this one vertically, and this one horizontally, and this one also horizontally, since they turn it 90 degrees. So we know it's 4 times angle, and angle is 36 degrees or pi over 5. So if we were to split this by 2, right, the angle divided by 2, since we're splitting this shape into 2 triangles, it would be 2 times pi divided by 5. And in this one, it's just going to be, at the common angle, it's just going to be pi divided by 5, because we divide by 2 and they multiply by 2. So just mentioning it out here. So we'll create a constant for the types. We'll call it types equals, let's say, an object. And we'll just have 1 colon, and we'll have, in here, we'll have like color. Let's say 1 is this one, for example. I'm not even sure which color it was, but we'll see. We'll figure it out. So color, and I'll have angle, which will be the common angle. And the angle for the first one, which we said was the small one, will be this one, which is 2 times pi divided by 5. So 2 times pi divided by 5, right? and we don't have access if I'm putting the constant here and not after setup has been called, the variable pi won't exist, so I need to use the math.pi variable, which I believe should be as accurate, the same variable as pi. It's just that they put it also into pi afterwards. But anyway, doesn't matter. Okay, great. So that's one. Type 2 should be, I could put this in an array as well, but doesn't matter. Type 2, it's the larger one. Right, so it's the larger one. Let's just take a different color. Hopefully this color is good enough. We'll see. We might want to move them around afterwards. We'll see what it gives us. And the angle should be just pi divided by 5. Great. And now let's copy those two for 3 and 4, since they have the same angle, just the color that we want to change. So 3, 4, color will be this one, let's say, for 3, and this one for 4. Great. Okay, so now we have our objects of types. We can remove this color array. I'll remove the config. Technically, maybe types I would put in config, doesn't matter for right now. Okay, so we have AB, which are vectors, and we have type, which is a number between an integer between 1 and 4, including those two. So if we take a look back, so we need the middle point. So I'll call it D, just like we had on the whiteboard. So D is equal to the lerp, a new vector that is lerp at the middle point, basically, of A and B, right? So lerp of A.x and B.x at 50%, and Y is the same thing, but with Y. Not really complicated here. Well, I mean, we've done all of the difficult part on the whiteboard, so we're good. We've got all of the logic already worked out. So we need the opposite length, right? The length between B and or A and D, or D and B, or vice versa, right? So const, and I'll call that opposite, equals. We can get the distance using P5, the distance between two vectors in P5. We can use P5.vector dot dist for the distance, and we pass our two vectors in here, which is, let's say, B and D, doesn't matter. As long as we have D and whatever A or B in there. And what else we need? The bisector value, right? So let me go back to this one over here, right? The bisector, which is the which is opposite divided by tangent of the angle, right? Const, and this is the bisector length. Sector equals the opposite divided by, I believe, mat.tangent, but possibly P5 as a tangent function. Let me check. Yeah, they do. Yeah, so we're good with that. Let's just use tangent. Tangent of the angle, and the angle is based on the type that was passed, right? So what we can do is types index type. It could be like type index, but it's fine. Type dot angle. Okay, great. Let me go back here. Okay, great. So we have our formula for the bisector. Now, we need to return the new point, right? We need this new point, P5.vector, and we need to use the sub function, just like we said, to move back to the origin, to basically get the vector from D to B, which is subtracting D from B, so B minus D, and then rotating by 90-degree counterclockwise, meaning minus and 90 degrees is half pi in radians. Again, these are also values in radians, so degrees, we said it was 36, I believe they were saying in here. Yeah, 36 in degrees, but we will use the radians. And then what we need after rotating it is to set the length of that line, of that vector. So set magnitude for setting the length to what we got from bisector. And then we need to move it back to the original position of D, right? There we go. Let me format this. Great. So now we have our apex function done. That's it. Wasn't too bad after we've done the complicated part. Now let's create our class Penrose. Yep, triangle. Constructor. So it'll receive A, B, and C, and its type, right? Okay, great. So this dot A equals A, this dot B equals B, and this dot C equals C. Straightforward. This dot type equals type. Okay, and we have two default values we need to set, which are for subdivided, true or false. This dot sub divided equals false by default, and this dot divisions, I guess, equals an empty array or an empty list, whatever you want. It's fine. We're not here to be picky on the concepts. We're just here for the concepts. Sorry. So we will have a function called subdivide, which will not receive anything. I don't think so. Great. And now we want to refer back to what we had on the whiteboards. Let me see here. So I will switch back and forth between this and this. Basically. So let's say right now, we'll do type 1. So we need to create the 4 and the 1, right? So if this dot type equals 1, then this dot subdivisions index 0 equals a new Penrose triangle. This is why I didn't want to write it on whiteboard with this whole thing. It's a bit long to write, and I don't have that much space. Okay, so we've already done that logic, so we can just take a look. So it's this dot C, and this is for the 4. So this dot C, this dot A, the apex between C with this dot C, this dot A with 4. Okay. So this dot C, this dot A, pretty straightforward. So, and oh, I do have them from here, right? There we go. Let me maybe zoom in a little bit more. Okay, so these are the ones, right? So this is our type 1, type 2, type 3, and type 4. So this dot C, right? Because we're going from it's a bit offset. Just turn it in your head. Turn your head 90 degrees. You'll be good. No, but we need to create this purple one right here, which is the fourth one. Also, in our case, this is 1. This is 3. This is 2, and this is 4. It's just anyway. So in this case, the A point is the C point, and the B point is the A point. So C, this dot B, and then we want the apex of those two. So apex of this dot C, this dot A for type 4, and then the type is going to be 4. I think that's it. Great. Okay, good. So we're done with this triangle. Now we need triangle number 2. And we only have 2 triangles for this one. Two subdivisions, I guess. So we said to get this small triangle, we want So this is A of this small triangle, which is B of the larger one. So this dot B is A for the other one. And then this is the C point of the one we created just before. So we can get that. We don't need to recalculate the apex. So this dot C. And then this one, the last one, the C point of that new one is just the C point of the current one, right? So this dot, no, sorry, the A point of the current one. And then the type should be the same as the current, so 1, right? Pretty straightforward. Okay, great. So we've done that type. Else if. Now, if type equals 2, right? So the 2 is this one for us. We could have done it a bit differently, but it doesn't matter. So type 2, right? And hopefully this is right. Yeah, this seems right as well. Okay. So else if type 2. So we need to, let's first create this one, since we already know 2 of the points. So this one is the same one as the current one. So we'll just create this like that, which should be a new triangle. The type should be 2. Correct. Yeah, correct. And then the A point is the B point, so B. And then the B point is the C point, and then we just need B and C over here. And that's it. Okay, great. And now we'll do this one over here, since we know those 2 points. So let's copy this. Let's change to 1. And this is going to be of type 4, right? It's not the same color here. It's not the same weight for the color. Anyway, okay. And so for the A point, it's the same as the current one. So this dot A. For the B point, though, it's going to be the A point of the, sorry, was I looking at the right? Yeah, okay. So the B point is going to be the C point of the one we created just before. So the C point of this one, this is for B, C point. The apex, we want basically to pass those 2. There we go. The type is 4. So we're good with that. Okay, there we go. And we need one last small triangle for this one. So let's create it. So this will be 2. So we already have those 3 points, so we don't really need to call apex. The first point is the C point of our current, this dot C. B point is the C point of the last one we did. And the C point is the B point of the previous one. So dot B, correct? Yeah, or the C point of the first one. In both cases, it's the same. And this will be of type 1, right? It's the first triangle. Okay, great. So we've done the second subdivision rule. Else if subdivision rule 3. Type 3, there we go. Type 3 is this one. So we'll just copy this and we'll just update the variables. So the first one we can create will be also the big one, which is fine, but in this case, it'll be the light one, which will be the type 2 for us. This might be a bit confusing, this part. Hopefully you get what I'm doing. So the A point is going to be the B point. So this is a B over here. And then the B point will be the C point. So C. And then the apex, we can just get that from the apex function. Great. Okay, and then the second is going to be 3 as the type. And do we have all of the 3 points? Yes, we do. So it's going to be the C point of this one as the first A point. And the B point is going to be this dot A. That's fine. Was I doing it properly for this one? Give me a sec. I just need to think about it. So this is the B. is the first one. Yeah, okay, that's fine. Yeah, never mind, sorry. Yeah, so this dot A is the B point of this one, and then this dot C should be the last one. No, this dot B is the C point of the other one. And this is type 3, right? Yes. Okay, great. Now we just need the last type. So else if type equals 4. And we're going to paste this in. Give me 1 minute. I'll be right back. Well, it'll be a couple of seconds for you. All right. Yeah, sorry. Where were we? Type 4. Yes, the last one. So, last one. We'll start with this first one. So, it's going to be a large triangle as well. So, it's going to start, A is going to be the C point of the current one. So, C. And then B is going to be the A point of the current one. And then the apex is going to be between those two. And it's going to be of type 4. So, we know that. So, type 4. Let me put 4 over here. Great. So we have this purple one done. Now we'll do this one, which will be A point will be the C point of the previous one, and B point will be the B point of the current one. So we'll need this value here. So this will be the A point. So C will be the A point of the new one, and then B will be this this dot B, right? And we'll just copy these two and put it into the apex function as we don't have the apex yet. And the type will be 2. No, sorry. Yes, 2. getting there. Okay. So, is this right? I believe so far it is. Okay, now for the last one, we already have all of the 3 points. So the first one should be the C of the last one we did, which is this one. Just want to see. Yeah. C should be this dot C of the last one. Okay, and then B should be our current C. So this dot C. And then, and then the last point should be C of the, we can use this one as well. C of that, is it C? No, it's going to be A of that one. No, yes. And it's going to be type 3. Okay, I think we're done with the subdivision rule. I think we're pretty much there. We just need to show it and make an action so that we can see the different version. All right, so I'm going back here, right? This is just our current sketch. We don't have anything. So what we'll do here right now in our subdivide function, we'll just set this dot subdivided to true at the end. This dot subdivided to true. There we go. And what we'll do is if it is subdivided, we can just call subdivide for all of the other ones. So for const pt for Penrose triangle of this pt dot subdivide, great, and then early returns, since we don't need to subdivide again, we've already done it. Great. And let me copy this because we'll be using it for show. But okay, so now if now we'll do the last function, last method I believe we'll want in that triangle, so called show. So the show function is just going to fill a triangle and draw a triangle. So first thing first, fill of types index this dot type dot color and triangle at this dot a dot x, this it's a bit long to write, but this dot a dot y, this dot b dot x, this dot b dot y, this dot c.x, this.c.y. I believe that is it. And if it is subdivided, we don't want to show this triangle, we want to show the subdivision. So we can just call show on the subdivisions. I think we're good to go. So what we just now need is to start with one triangle. I'd like to start with a larger one. So let's say type 2 or type 3, and we'll see. So we'll have like let T for triangle, I guess. Sure, I'm just a bit lazy with my names right now. A new Penrose triangle. Now it's the initial first 3 points, which will be create vector. The first point, A, will be, let's say we want it somewhere over here, somewhere, right? So middle, a bit more, maybe a third of the way through. The height, and 100%, 100 pixel from the edge. So 100 from the edge and a third, 2/3 of the way through the height. So height divided by 3 times 2. Great, we'll copy this for B, but B, it's going to be the same height, but it's going to be the width, 100 pixel from the edge as well, but from the other edge. Okay, and the C point, not complicated, we'll just call apex, and I'll just call those two, I'll just initialize those two outside over here, call them A and B, I guess. And hopefully you get better variable names than mine. I'm just writing stuff right now. I'm not really worrying about that. I'm the one that's going to maintain that code, which is not going to be maintained at all, I'm guessing. Just going to make it work, and that's pretty much it. If you want to make contribution, please feel free. You can make a pull request if you know how to. Yeah, there's many videos on YouTube for that. Okay, great. So we do have a triangle showing up. That's a good start. Great. Now it's not subdividing right now, which makes sense. We haven't called subdivision. So what I'll do is on mouse press, I'll just call subdivision here, right? So t dot subdivide and t dot show. And what we'll do is redraw the background before showing it, or yeah, that's fine. Okay, so let's see. There's an error somewhere. Reference error. Type is not defined at triangle that subdivide. Triangle that subdivide. Line 61. 61. Let's take a look. Oh yeah, it's this dot type, right? I guess I forgot it for all of them. Well, apart from the first one, it seems. Okay, there we go. Okay, let's see. Okay, seems right. Seems wrong. Seems wrong again. And wrong, and wrong, and wrong. So on and so forth. Okay, so this one is right? I think so. Let me close this. Let me refresh. Does this look right? I guess I might be wrong with my angles and stuff. Oh, you know what? This angle is not right. It's not the one we need. It's the 180 minus 90. So pi, which is 180, minus 90, which is half pi, makes sense, minus this, right? There you go. That looks more like what I was expecting. Right now, if I clicked, okay, it's good. It's looking a lot like what I were expecting. Oh, though the colors, I might want to exchange the color between 3 and 4. Let me see. Wait, did that do anything? I want the dark blue to be also a big one. So dark blue should be, so since we started with 2, it should be, a dark blue should be on the 4, but right now it's on the 1. So this value should be on the 4, and the 4 should be on the 1, right? Let's see. Yeah, okay, great. So we have an issue. Let's see if we can find what is wrong. So this one is good. This subdivision is okay. So so subdivision for type 2 is okay. It is fine. So subdivision 2, it's okay. We can close it. Subdivision for type 4, this one, and this one is 1, and this one is 2. Let's see. So type 1 is the issue. So this subdivision is bad. So what did we do wrong in here? So, or maybe it is this one whenever we create this last one. Let me take a look back at this one, right? So we create type 1 using this one, right? From this.c, it is correct, this.c, to the first one .c, the first one .c. No. Second one .c, that's right. And then .1 .b. That is also correct, I guess. It is fine. Okay, so that's fine. That's all dandy and good. So this type 1, let's see, this is the type 1. So we need to subdivide first with the big one, which is from C to O, and let's see which one is wrong. So the small is okay, but large is not, right? And is it correct? Let me see if I rotate it in my head. This is correct. Yeah, 4 is not correct. I guess it is maybe the angle is bad. Let me take a look, make sure I do minus half pi. That's okay. Let me go back here. So so it's not the small one, it's the big one, the issue. So yeah, there you go. It's to B. The apex should be going to B. There we go. Let me see. Let me refresh. This .c, which is this point, is the A point of this. B is the A point. Oh, A, okay, I didn't change the right one. Okay. This should be right. Yes, okay, there you go. There we go, we've done it. We've done the Penrose tiling. There is definitely other ways to do this. There's other also variation of the Penrose tiling. This was just the one I did. Hopefully it helped you. Let me know down in the comments below if I was mistaken with any of the things I said during the explanation. And leave a like if you liked the video and want to see more of this. Thanks for watching. See you in the next one. Bye-bye.